So question 5, work with vectors. It says, given the endpoint of the vector in rectangular coordinates, find the polar coordinates. So they want to change to one coordinate system to a different coordinate system. So if I'm talking about rectangular coordinates, 4, 7 was what was given. So the x coordinate and the y coordinate, we have this 4 and this 7. So if I graph this 2, 4, 2, 4, 6, 7, so then the vector would be there. So I can kind of make this happen. So the vector kind of travels from this position to this position. So this is our vector. So in polar coordinates, we just plot the x coordinate and the y coordinate, and that will create the end of the what's called the head of the head of the vector. So this is the tail and this is the head where it finishes at. So it begins here and it ends here. So notice that the vector can be created by just knowing the x and y coordinate. Now, to create polar coordinates, we need to know the magnitude and the direction. So if I know the magnitude and the direction, that's going to create what's called polar coordinates. So to find the magnitude, that's our Pythagorean theorem guy. So the square root of x squared plus y squared will give us our r. And then to find the angle, the inverse tangent of y over x to find the angle. So to find the radius or the magnitude of the vector, we're going to have 4 squared plus 7 squared, and we're going to take the square root of that. And it does say round to the nearest tenth as needed. So we have the square root of, let's see, get this thing working here. So the square root of 4 squared plus 7 squared, that'll give us our magnitude or our radius, if you will. So it's going to be about 8.6. So 8.6, or 8.1, I should say. So 8.1 is going to be our magnitude. And then our angle is going to be the inverse tangent of 7 over 4, y over x. So that would create our angle. And it looks like, based on this drawing, it looks like it's around 60 degrees or so, maybe a little bit more. My drawing's not really all that great, but inverse tangent, and then we have 7 over 4. Remember, I'm already in degree mode, so it should kick out it in degrees. So that would be like 60.3 degrees. So 60.3 degrees would be the direction. So in polar coordinates, what you can do is rotate 60.3 degrees, but you also have to have a length of 8.1. So if I have like this 8.1 here, so 2, 4, 6, 8.1 would be about here. But if I rotate that on a circle, on a radius, if you will, 60.3 degrees, so you're going to have then, so if I rotate this 8.1, 60.3 degrees, that would give me the position of my tail. So notice that you're almost like using a compass to draw a circle, but we're not drawing the full circle. So 8.1 is about here, but if you had a compass, you'd be rotating that out to about here. So the length of this is 8.1. That's like the radius or the magnitude of the vector. And then theta is how far it rotated from standard position. Remember, the x-axis, the positive x-axis is standard position, so that would be 60.3. So by knowing how long the vector is and how much to rotate it, will create the location and direction of the vector. So how long it is and its direction. So there's two ways to locate a vector. One is knowing its magnitude and its angle. So in this case, 8.1 is the magnitude and the angle is 60.3 degrees. The other way is just plot the order pair on the x and y axis, and that create the location that way. So we have two different coordinate systems. One is called rectangular coordinate system, and then The other one is actually what's called polar coordinate system. So in a polar coordinate system, you need to know how long the vector is, and then you need to know how far to rotate it in degrees. Now, instead of using formulas, we can use the calculator. So notice under angle, we have R PR and R P theta. So this kind of means rectangular to polar, and this kind of means rectangular to polar. But the first formula will do the magnitude. The second formula will do the angle. So if I choose number 5 to start with, so what we need to put in here, I believe, is the ordered pair. So 4, 7. So if I put 4, comma, where is the comma at? Here's the comma above the 7. So if, this kind of means rectangular to polar, but what it's going to do is find the magnitude. So we should get 8.1 here. So that's how that gives me the 8.1. And then if I go second angle again, notice how R P theta, that means it'll find the angle in polar coordinates. So if I choose number 6, so all I got to do is put the ordered pair in, this 4, comma, 7, and that formula should give us the angle of 60.3 degrees. So that does give me 60.25 again, 60.3 degrees. So you can also use a formula, or you can just use these formulas. So we have a program here or these formulas to get the same answers. So those are the main two formulas. You know, it's kind of the Pythagorean theorem and then the inverse tangent. So those aren't hard formulas to remember, but also we can use technology to find those same answers.